Milk is produced in 970 farms countrywide. The national dairy herd comprises about 120,000 milking cows of the Israeli Holstein breed, developed by our genetic improvement system. The Israeli cow has been selected through generations and is well adapted to the harsh environment, long and hot summers, as well as several endemic diseases. The minimum and maximum temperature during the year, and here you have the THI. The THI is a combined effect of temperature and humidity that explain the risk of heat stress to cattle. When the THI is high, it affects the body temperature and it affects the performance. When THI is more than 72, the cattle is under heat stress, and you can see that about 6 to 7 months in the year, the cattle is under a very hard heat load. You can examine the average temperature, and I choose August from 1963 until today. You can see there is an increased temperature during the years, but something more important to see is the daily hours that we have more than 25 degrees during the years. You can see there is a constant tendency of prolonged heat waves with longer hot season and multiple hours of heat waves. This is a big problem for animals, producing animals. The constant rise in global warming is decreasing the milk production during hot seasons globally. During the last 30 years, Israel Research has conducted studies and surveys to develop efficient management which may allow high milk yield during hot and humid summer. We gain indicates that both high productivity and production efficiency can be obtained when efficiently treating cows in summer. Similar results can be expected in other dairy sectors from hot regions of the world in the future. In years, you can see there is an average increment of about 100 kilo of milk per cow per year. Take a look also the fat percent and the protein percent is increasing during this time. We also can see that the daily yield kilo per cow, depending on the monthly recording in this last 30 years, you can see that despite the seasonal gap, this is the summer, environmental factors as temperature, humidity, radiation, air movement, and precipitation. Heat load in dairy cattle raise the cow's body temperature due to reduction in the temperature gradient between skin surface and the environment. The heat load accumulated by the cow is subject to heat stress is the sum of heat accumulated from the environment and the failure to dissipate heat associated with metabolic process. Neutral zone that is more than 20 degrees have detrimental effect on the dairy cow under intensive management. Cows during the hot seasons that make a decrease in pregnancy, problems with the follicular development and the implantation of ova in the uterus, leading to a decrease of calving on spring and next summer season. We have decreasing effect on cow's spirit weight and colostrum quality, and damage in development of the epithelial cells in the mammary gland of dairy cows during the dry period. So what are the clear signs of heat stress? Increased body temperature for more than 39 degrees, respiratory rate over 60 breaths per minute, and drop of food intake and milk about 10% or even more. But dairy cows usually can dissipate excess heat by sensible loss of heat by radiation, convection, and conduction, active loss of heat by panting and sweating, but cows are limited ability to dissipate excess heat. So The meaning of this is that we have to help the cow, and the methods for managing heat stress. Number one is the prevention or reduction of solar radiation by shading, whitening of roofs. The second one is one of the most important, direct refrigeration of the cow by showering, wetting, ventilation, or a combination of showering and ventilation. Number three is a combination of direct to the cow and indirect refrigeration of the environment, using system of fogging or misting, coolers, or maybe air condition. And number four is the adaptation of feeding to heat load conditions. So the cooling system developed and first implanted in Israel for more than 20 years ago is a combination of wetting the cows frequently, followed by blowing air with forced ventilation. We're talking about 6 to 8 cooling periods a day, each period between 30 to 45 minutes, 5-minute cycle of half minute of sprinkle and 4.5 minutes of forced ventilation, altogether between 4 to 6 cumulative hours a day. This is an experiment we did 4 years ago. You can see a very high producing cows in the summer using a cooling system, and then suddenly we stop cooling the cows. We can see a detrimental decrease in intake and in the production. Showering and the ventilation in the holding pen of the milking parlor, put together all the cows. You can see ventilators and sprinklers in the roof, and this is the way we are wetting the cows in the milking parlor. Here we're cooling and showering and ventilating along the feeding lane. Another system, take a look at the barn, very big, very tall barn with a chimney, so the hot air is blowing out there. Ventilators with sprinklers. Another example. We try to study what is the optimal frequency of cooling treatments. So we check the temperature of cows with different yield of milk under intensive cooling system. And here we have two different cows, 9,000 kilo a year. This is a cow from 30 years ago, and a cow of today, the black cow, having 12 tons of milk. And you can see that the old cow with the low yield milk, after a good cooling system, can stay about 2.5 hours until the body temperature is going more than 39 degrees. But the black cow, cool in the same intensity, were not able to maintain the normal body temperature for the same time period, and after 1 hour we have to do something else because the body temperature is more than this 39 degrees. The system of combination of cooling the cow and cooling the surrounding, the idea is that the milk increase constantly, and because when we have higher milk, it increases the metabolic heat production and the sensitivity of the dairy cow to heat load. So in this case, the frequency of cooling should be increased. We know that cows lay down about 8 to 10 hours a day, and no cooling is performed in the resting place, mainly because the requirement of keeping the place dry. So cooling the air in the resting area, be a moderate fogging system, may relieve the cow's heat load in time between intensive coolings. An additional system of cooling the surrounding by water evaporation using fogging system may be possible in areas where the temperature is high and the humidity is low, less than 47%. The inside temperature in the barn maybe between 4 to 6 degrees lower than the outside.